My name is Mike Brooks, and I'm with Phoenix Contact. Phoenix Contact, not necessarily a household name, so as a company, we kind of compete with a Rockwell or a Siemens. We always joke we're their little brother. If you look at what we do, we are a manufacturer. We're 100 years old. We're a German company, still privately held by a family. We have about 100 manufacturing locations around the globe. We're very vertically integrated as a company, and we do about $4 billion in revenue. But what we make is kind of why we're not a household name, is because we sit behind a control cabinet somewhere on the factory floor. So if you go and look at a machine that's on the factory floor and you look at the electrical panel, there's going to be some of our stuff back behind that, but it's not out on the mainstream kind of thing. The company started by inventing something called the terminal block, where the wire attaches. We invented that back in 1923. So that's where we started, and today we're a full-line electrical automation vendor. So I'm out of the Detroit area. I'm out of Michigan. This was Monday in Michigan, which was a snow day for the grandkids. So we had them all over ice skating, and that was about 4 degrees. But Michigan kids are pretty tough, and not to say Tennessee kids aren't tough too, but it doesn't stop them from getting out and enjoying things. So it's nice to come down here for a little break from the weather, even though it's 40 degrees is a break for us. I'm going to talk today a little bit about, the theme here is digital tools for improving your operational efficiencies. So I'll talk a little bit about what does it mean? What are these digital tools that are available to us? The main crux here is to provide real-world examples of things we've done that help customers to help improve their processes, either by improving equipment uptime, by improving quality and traceability, or by improving energy efficiency or reducing energy consumption. So if you look at all the use cases that we say we just need just a little bit more data to get a little more insight into our operations, it's always going to end up in one of those 3 categories of what is the problem that you're trying to solve. Again, machine utilization or OEE, quality/traceability, or energy efficiency. So with that, I'll start with a little video here, and I got to kind of jump out and back in.
Are they skating down a pond?
Yes, yeah, that's a pond behind our house, yeah.
And you just kind of scraped the snow off and said, go at it?
Oh, yeah.
Oh.
So.
Good morning. What's your overall equipment effectiveness like today? I can see the red lights on. The LED can't be doing that good. What's the story with it? Thanks for the update. Hey, good afternoon. I was curious, what barriers are impacting production today? Hey, thanks for the update. Hey, good afternoon. Do you have any ideas or suggestions that can help us with our output? I like that. Let me go look into that.
The future is bright and robots are cool, but we're not quite there yet. Here's where we're at today.
So that's kind of, I'll say that's cute. But that particular gentleman, he's actually our production supervisor in Harrisburg, Pennsylvania, and what you saw there was our production facility there. We started as a company, we started looking at Industry 4.0 as a topic, gosh, it goes probably almost 10 years ago. And nobody really, it's kind of like AI is today. What does it mean and how do we use it in our business? And we didn't really know. But we said, hey, before we can go out and talk to customers about it, we should probably learn to walk the walk internally. So we began our own digitalization effort back then. And we took a plant in a town called Bad Pyrmont in Germany, which was our electronics plant. So stuff you see there, making circuit boards, stuffing them, making plastic housings. And today, that plant is, we call it a pilot or a lighthouse plant. It is 100% digitalized. Every piece of data off the factory floor is consumed and used there. What do we often hear when it talks about data, if an automotive company, particular in automotive? I remember going in when this topic was new. I went to talk to the guy who was head of controls for Ford. And he goes, Mike, he goes, I have terabytes of data sitting on servers all over the organization. He goes, I don't even know what to do. We have so much, we don't need any more data. He goes, but the problem is, when I'm looking at machinery, I don't always have access to some of it. And we always look at, okay, IT's the bad people, right? They're isolating it. It goes to the MES layer, the manufacturing execution layer. It goes to the ERP layer, but we can't get access to some of the data. So I'm going to show you ways that we can do that very cost effectively and very non-intrusive sort of ways of getting data off the factory floor. The other thing I'll mention is you don't need a lot of data to get insights into solving problems. So the first thing you really need to do is, what's the problem that I'm trying to solve that maybe just a little bit more insight would help me to do? And I'll give you some real world examples of that. So to begin with, let's talk about what are the digital tools I'm talking about. So on the factory floor, and I may be a little bit out of order here, but first thing is I've got a machine out there and it's got data in it. It's got a PLC, it's running, it's doing what it does, and it has information in it, inputs, outputs, etc., cycle times, and a lot of times that is connected to some higher level system. But I don't want to go in and modify that machine. That machine has to stay running. So in order to get the data or maybe additional insights, I cannot, or I could, but I have to shut the machine down and I have to reprogram it to get some data. So how do I do this so it's non-intrusive? Well, we call data collection or edge devices. So these are things that can extract data from the existing operation. The program resides in the edge device and it simply connects via Ethernet IP or Profinet, some protocol, and pulls out data out of the machine but does not disrupt the production operations. Now maybe I need just one more piece of information that's not on the machine, or two pieces. So that we'll sometimes add sensors, vibration, temperature, humidity, some other type of sensing data, current sensing, like energy collection devices, which you see on the left there. So now I've got my machine, I'm extracting data from it. I can aggregate that data, I can collect it, and now I need to do something with it. So I'm going to forward that data. I can either do it locally on the edge, I can process that data and say, okay, I'm seeing these trends based on the data sets that I'm extracting, or I can forward it to a higher level supervisor that something like Ignition or some other software platform. So that's the next step, is the storage and visualization of the data. And lastly, and at that level, you're going to begin to analyze the data. But it sounds complex and maybe costly, but I'll show you where it isn't, based on some real world stuff we've done. So this first application is actually a Chinese, and for the VW folks in the room, they probably recognize this is what's called a very large transfer press. So this thing has got 4 stations up above each station here. There's approximately a 500 horse motor that runs, and there are 4 motors on each of these presses, and these presses stamp out the large metal parts that you find on the vehicle, the fenders, the hoods, the decks, etc. And there are 5 of these lines at that press. When those presses go down and they feed the production line, it is a hard go down. And if you can imagine pulling a 500 horse motor off the top of that press and replacing it or servicing it, it can lead up to about a week's downtime in some applications. And historically, they're not monitored, right? They're just running, and when they fail, they fail. So what we did is we simply added two things. We added an energy monitoring device, so we took and measured the current of the motor, and we also took a vibration sensor. Sum those two things together, and that produced a plot that we see on the right-hand side there. What I call it like a signature. Each machine, as it operates, as the press cycles, you see the current will go up and down, but it usually runs within norms. But as bearings begin to wear or windings start to fail, you'll see changes either to the current or the vibration, one of those two things. So now that I have the visualization of the machine and I would say its standard operating process over time, I need to do one more thing, and that is to just provide the analytics on that. So in this particular case, it's a form of AI, it's called machine learning, but it's simply, machine learning looks at patterns. It says, here's a pattern, I see the pattern, the signature, and I say, okay, as it begins to drift out of this window, I'm beginning to see a predictive maintenance event. And so I can begin to analyze and say, before the motor fails, let's take a look at it and let's schedule downtime. I think everybody understands those concepts very simply. But again, this one device, or you have one of these at each press or each motor, then one of these on the press line. So for the edge controller and its data collection box, it's about $5,000. Each one of those energy monitors about $1,000. So for under 10 grand, you can look at this whole press line and get predictive analytics out of it. So you hear me say this over and over again. It doesn't take a ton of data. It doesn't have to cost a ton of money. And you don't need to send all your data to the cloud to make all your dreams come true. You can do all this stuff very locally and just solve the problem locally. Not to say you can't and you don't want to push it up to a higher level system, but a lot of these problems can be solved right at the point of use with just a little bit more information. So this kind of shows it graphically, and there's the other thing that we did here is over time, we took the data out of each press and we put it up. This is just simply a server which says I'm going to collect the data and keep it for data storage over time so I can go back and revisit any anomalies that might have occurred. So we just forwarded it up. That was one more step we added. All right. This next one is an application we did directly at Phoenix Contact, again at our Harrisburg facility. So I'll show you that. We've got that on a video here.
In the world of manufacturing, uptime and productivity are the typical benchmarks for success. Reliable machines that have been churning out quality products for decades are trusted with unwavering faith. After all, if it ain't broke, why fix it? But in the 21st century, manufacturers who resist new technology and automation are putting their business at risk. Phoenix Contact just celebrated its 100-year anniversary. And the secret to our success is our passion for technology and the everlasting desire to continuously make things better. Driving efficiency is the key to ensuring the longevity and sustainability of your manufacturing business and to becoming a smart factory of the future. That's where data comes in. Imagine having the power to obtain, monitor, and analyze data from your machines in real time. Let us show you how we did it at our U.S. Manufacturing Center in Harrisburg, Pennsylvania. The first goal was to collect energy consumption data from the machines in our manufacturing plant. Utilizing our own products was essential to complete our goal. Electrical energy monitors were hooked up to several machines to collect data reports on daily energy consumption. We began by monitoring 3 of our production machines: the VIP slice machine, wave soldering machine, and the SMT line. Next, we needed a solution to harvest the information from these machines. The Emperor was selected to monitor the wave solder and VIP slice machines. M-Pro energy measuring devices can be configured and integrated into a network in minutes, and it provided a straightforward method for measuring single-source power. Installation was simple, and the M-Pro can also monitor the entire machine. The surface mount technology, or SMT machine, required a higher-level solution that was implemented using an MQTT broker and products including a PLC Next controller and axial line power monitoring modules to gain a complete picture of the whole line. And the monitoring and collection efforts are only valuable if we take the time to study the data and identify insights in operations or possible faults. The information also has to be readily available on our internal network for any groups that will want to use it in their applications. For example, production supervisors may want to chart energy usage for predictive maintenance, while the plant manager may want to use it for cost analysis. All the data we collect can then drive our decisions.
So I believe the goal of our energy monitoring project is to collect the data that we're getting off the shop floor and use that information to make intelligent decisions for our manufacturing processes and make energy saving and conscious efforts to reduce those energy footprints that we currently have now.
This is what energy monitoring can help us do: digitize and create value with existing assets, ensure uptime and reduce costs and complexities with predictive maintenance, improve scheduling and streamline workflows, access to dashboarding and analytics anytime, better allocate human tasks and responsibilities, identify supply chain issues, improve system interoperability, avoid data silos and stovepipe architectures, create database decision models. Now, how can we help you? Join us as we explore the new frontier of energy monitoring to promote efficient and sustainable manufacturing for all.
So there we started with a, I mentioned, excuse me, when you're starting down this journey, I suggested, and this is the parent, right? Do as I say, don't do as I do. We put these energy monitors out there without really any idea of what we wanted to achieve. It's like, we'll just pull some data off and then we'll look at the data and see what we get out of this thing. We didn't have an end goal in mind, but kind of a cool thing that spun out of that and the learning for us was they talked about monitoring 3 lines. And if you look at a printed circuit board line, you have a board stuffer, the SMT line, the surface mount technology, takes all these little chips, picks them off, they come off a reel and it stuffs them all in the board. Then the next step is it goes in through a wave soldering machine and the devices get soldered and then it gets assembled on the output side. So in monitoring the wave soldering machine, and again, the view was energy consumption and conservation. We found, and we saved almost 30% energy savings, because what we found on the energy side was that we had this thing either on all the time or off all the time. And if you picture a vat of soldering flux or stuff, it takes a while to heat it up, but it takes a little bit of energy to keep it running. And we had downtime. We had only running that machine on 2 shifts. We'd lose an hour of production on the front end while this thing heated up. So we saw that through the analysis. The other thing we saw is on shift changes, it was maintaining its constant temperature. So we looked at shift changes, we ramp it down, not where it gets hardened, but enough to reduce the energy consumption. So those 2 things produced a tangible result on the energy thing. But what I've seen now time and time again, if you want to go and look for an application to where to apply this technology, start with energy, because you will always get a secondary benefit of some equipment utilization issue. So the real benefit we got out of this was the utilization we found on that wave soldering machine was only at 50%. So we saw this thing with massive amounts of dwell time, and we're like, why? And it was because the upstream equipment, the stuffer, ran at about 50% of the speed of the wave soldering machine. So that forced us to then go look 1 step backwards and look at the board stuffer and go, either can we make this thing run faster, we have to run parallel production and set up a second line. And what we found through that analysis was that one of the reels was the Achilles heel of this whole thing. So we were able to improve that, get the front end equipment running at about the same speed that the wave soldering. So it had started by looking at energy over here, but resulted in much better machine utilization. So we got 2 benefits out of that. The other reason I would suggest, out of all these different things that you can do in terms of, I'll say, use cases around why should I do it, some form of digitalization effort, energy is the easiest one to justify from a budget perspective, right? Because if I can save energy, I know my energy costs, it's the easiest one to calculate ROI. OE is always a difficult one. I know I'm going to improve the process, I may improve machine uptime, but how do you quantify that to go get the budget? That's always a little bit more of a challenge, unless it's an absolute major problem that's creating a lot of line downtime. So again, if you're to start this journey and looking for something simple to start on, start with energy. And again, it's simply adding an energy monitor. That it can be that simple. Because if you think about energy, how do we monitor energy in our plants? It's really at the mains, right? It's maybe at a substation level. But if you get granular and you start looking and you get measurements down at the machine level, now you're getting insight into the machine itself. So you're always going to get an energy savings benefit, or at least consumption knowledge, but you're also more than likely going to see some fluctuation in that energy usage that over time is saying, maybe I'm starting to see the front end of a problem here because I'm watching current go up. So getting granular, it's a low-cost way to implement IoT. Okay, so I've told you how great Phoenix is, right, as a company, and we really got our stuff together and we really know this well. How many people have gotten into their plant pieces of equipment with no budget to implement them on their factory floor? Never happens. Happens at Phoenix. So these guys, we injection mold, if you look at these parts inside their circuit boards, but on the outside there's plastic housings, right? And so we have 150 injection molding machines in Germany that would inject the parts, send them over to us as housings. So now let's bring at least that function over here to serve our local plant. So we did that with no budget. We bought the injection molding machines, there's 8 of them there, put them into place, not connected to the MES. You got 1 operator running 8 machines. These things were down because they had no way of knowing whether the machine was down, it was out of plastic, because this person's running around like a chicken with their head cut off. So what do we do to resolve that? There wasn't much budget to do it. The guy that you saw there, Russ, he's like, "Cripe, I gotta do something." So we took one of our little data collection boxes, about $5,000, and added it. That's this thing here. So this is the back end of the injection molding machine. We put one of those on there. So now we could go, we couldn't stop running these machines. We still had to create production, but we needed to get some data out of these things to either simply, the first step was simply enunciate to the operator, the machine's down. And then we added a second step of giving them the visualization that needed and connecting this thing to the MES layer. So we could have done all of that. We could have shut down the injection molding machines, connect it to the network, get all that done. But in doing that, we have to reprogram it. We take the line down. So by doing this externally, on the edge, so to speak, we were able to do it non-intrusively and get us the benefits that we needed. So when we're all done now, this one person can run 8 machines very flexibly, very functionally with very minimal downtime, because he or she can see whether the machine's down, it needs tending. All their workflow and instructions are there that are represented graphically. So that has saved us a lot of money, and it's all this stuff is relatively simple. This next one is, so maybe 3 years ago, I had a customer they build machines, and these are very high precision machines. They have 2 customers that they serve, either high-end automotive, like high precision stuff, throttle bodies on transmissions or fuel injectors. These are real high stuff that when you make it, you assemble it, and you measure it, it's measured in microns kind of stuff. The other half of their business in this particular machine was going to some form of medical equipment. But again, super high precision. And what was happening was they sold the machine, put it in, and over time they were getting false rejects because they were finding the parts were out of tolerance. You know, you had a single set point, so it was plus or minus. and they were having what they found to be false rejects, because they would take them out, send them over to rework, but when they would gauge them at the rework station, they're like, no, these are intolerant. These were intolerance. So a lot of wasted effort, but nonetheless, they couldn't accept them off the line, and they really had no way of changing the set points. The operator could have went in there and manually overrode the set points, but that really was done, that wasn't allowed and would not have been done in an intelligent sort of way. It would just make the problem go away, but we don't know if we were going to reduce it. So we said, hey, let's help you. He had gotten 2 quotes to go in and modify the machine code to get this data out and get the visualization of what was occurring. But it was about, the prices he had was somewhere between 50 and 80 grand to go in and do that. And he'd had to take the line down for a week or so to get the rework done that they needed. So we came in, he said, you know, I could do this if I can do it for 5 or 10 grand, I'll do it. And so we said, yeah, we can help you with that. So again, same thing, data collection box on the edge, and then we added in a little weather station. So this gave us barometric pressure, it gave us humidity, and it gave us temperature. And that produced then a graph that we could say, here's the gauge data, and then we could watch what was the effect. They knew something in the environment was the effect, they just needed the data to show it. Like, as excuse me, any of you in the room know, people on the floor, and many of you, you know what the problem is, at least you do, but you just need something to visualize it, to take to your boss or whatever it is. You just need a little bit of data to take to somebody to make the business case. All the knowledge is in the operators, I'm convinced. They know what the heck's going on. But many times they don't have the voice or they don't have the authority or whatever it is, excuse me. So then we represented, and they saw that, and it was really barometric pressure. As the pressure in the facility began to rise, this gauge data started to grow. The parts grow, but if they were taken out, the environment changed, they were back in tolerance again. So what we did then simply was we added the hardware. The next step was to add kind of the software, and it was just a simple machine learning algorithm that we included in the device to say, okay, as we watch this trend start to go back and close the loop and create an offset in the set point. So it was an adaptive tuning sort of situation where we'd adapt as the barometric pressure increased. We'd also increase the set point a little bit. And this reduced the amount of false rejects by over 95%. So the customer was happy, the machine builder was able to get paid, and life was good. But again, about 5-6 grand altogether, maybe another grand in software. This is where, you know, we're a hardware company, we provide all the hardware. You get people like Focus Apps who can bring this together, and maybe you have the talent in-house. But today, a lot of the young people coming out of robotics, they have great programming talent, and writing an algorithm or a little loop to analyze things, it doesn't cost you a ton. And lastly, this is something, again, go back to our friend Mike, our production guy in Harrisburg, excuse me. And this would fall under the, I guess, heading of augmented reality. This is using digital tools to help, you'll see.
Hi, I'm Mike Doyle. I work at Phoenix Contact USA. I'm production supervisor of the automated assembly area. So this digital app was created when second shift technician Amit Patel came to me. He had put a barcode scanner on a machine conveyor belt. He did that so that way we would have access to more information beyond the drawing package, where spare parts are located at and part numbers. When we took that barcode and we worked with the IT team to make it more secure, things started to brew, and we were able to add more technologies into the app. The goal of the app was so that way the technician never had to leave the machine to go find a manual that the vendor had provided. One of the benefits of this app is it's almost as if we can take the manual and add our own notes to it. So now we'll start with the regular drawing of the machine tooling. And if we drop a screw and we're not sure what the screw is, we can add that information in. We can also edit it and add in where the spare part is located at. We could even put in the costs if needed. It was very convenient when the application was presented to me, because at the time, management was asking to launch a third shift. And the transfer of knowledge is very difficult to take all of the history lessons learned that an aged or experienced technician has. This app allowed us to train our rookie technicians and get them up to speed much quicker. Third Shift has been using it, and they've been having very good results with it.
So again, that's all software. We did that in-house. We've got web developers and people like that that can do that stuff. But again, there's companies like Focus Apps that can help you with these augmented reality. In this particular case, it's displayed on an iPad. We've had situations with some of the automotives where they want to do it with, let's say, Google Glass or some forms of glasses where they can actually look into the machine and see deeper in through this augmented reality. So, but for us, it's a very practical thing. I was a maintenance guy long ago, electrician, and you go out to a machine and try to find either a drawing that was correct on it, or wiring diagram wasn't correct on it. So now with these live databases and access, it saves all the running around that you would have to do. It's been really helpful to our maintenance team in Harrisburg and really helped our efficiencies. So with that, I'm going to kind of summarize things here. So you've kind of beaten the same drum, right? My suggestion, if you're looking at doing this, is start small. Define the problem that you're trying to solve. It doesn't have to cost a lot. I'll give you an example. To go back to I'll just pick on the Ford guy, but a lot of the I would say larger organizations, they all signed up for, we're going to create what they call data lakes. We're going to take all of our information off the factory floor. We're going to put it up on a AWS or Google web server, and then our data scientists will go in, and at some point they're going to analyze it. And this goes back 5, 6, 7 years ago, and so now they have tons more data and still don't know where to go with it. The issue that we're seeing now, and I'm sitting in a meeting probably at least once a week with an automotive or another, they're like, okay, the bills come due now, because now they got all this data. That data is not free. And they're starting to get the bills for these Amazon Web Services and stuff going, how do we make this go away? And this is where we keep pushing, and I keep harping on, do it on the edge. Do it simply, do it there. You're not pushing all this data up. You're not consuming tons of bandwidth, on your network and on your factory floor. You can do everything on the edge, and only the result. Take it, aggregate it, analyze it, and then the result of it, send it up if it needs to go to some other enterprise or higher level system. So that is our suggestion for the approach. And again, all of that can be done for under $10,000, because that's the other challenge. If you're a small organization and somebody, the CEO or the owner, the president says, yeah, I'd like to dabble in this digitalization thing. This is the way to dabble in it. You have to kind of show it first and find the benefit for it. So again, and I've talked about this, doing it on the edge allows it to be non-intrusive. I don't have to go in and reprogram my machine, shut my machine down, or alter it in any way. Let the machine do what it's doing, let it run. If you look at what our edge devices, they look like, and they are at their form factor a PLC, but the difference is they're really a computer in a PLC form factor. A PLC does certain kind of programming, it does ladder logic, and it runs a machine. It does it extremely well and very efficient, but it's not necessarily a PC. It doesn't aggregate data, it doesn't do formulas and math and some of the more advanced things that a computer does. So usually you'll see a PLC and a computer. Well, that's basically what our edge device is, but the thing is, it's in a form factor that allows you to add maybe additional sensor or two. It has inputs and outputs. But what it is, at its core, it's Linux based, so it's open source. You can write in ladder logic, or you can write in some other higher level language to do these analyses and things. And that's kind of how we do it. So with that, any questions, comments, concerns? I'd like to understand what your organization's doing in this area.
For measuring the current, are you using an electromagnetic flux sensor, or how do you guys?
Yeah, so there's different, they're current transducers, and they can either be, I'm trying to see if there's a picture of one. They call them donuts, right? You run the wire through the donut, and the donut has so many turns, and it produces an output. And then the little energy monitor takes that signal. So that's how that works. So you have to add a current transducer to the lines, maybe the on a three phase, right? Three donuts. There is one technology we have out there. It's called a Rogowski coil. Because the downside of the donut is I got to shut it down. I got to disconnect the wires, put this thing, run through it, and they have a very specific output to we call the turns ratio. So a Rogowski coil is it's a straight thing. You just loop it around and you connect it, and then you scale it. So you don't have to buy a specific current one. You just buy a Rogowski coil. You can add it without disconnecting any of the wires. But it does the same functionality, and then that feeds the energy meter. The energy meter shows phase loss. It shows a lot of data, and then the energy meters have usually some form of communication, Profinet, Profibus, Modbus, TCP, whatever it is, that can send the data out of the energy monitor to the edge device or some other data collection. So those are the pieces. A current transducer is $300 or $400, so you get times 3 of those. You've got the energy monitor, it's about $1,000. So for $2,000, you're monitoring energy at the machine level. And a hush fell over.
The device you're talking about, how much memory does it have? I mean, to get to your point of trying to be less intrusive and use on the edge.
Yeah.
But you're gonna have some limitations on the amount of data.
Correct. Yep.
So kind of what's a range or a typical quantity of data? I mean, is it a terabyte? Is it
Oh gosh, no. No, the data. If you're going to store data, we'll pull data off. We'll analyze it at the edge. We'll do something with it. We'll produce a result, and then we'll export that. Then we'll start all over again.
You're not able to store too much on the edge.
That has about 2 gigabit worth of storage data. But again, if you really want data collection, you're going to offload it.
I'm just thinking about though, as even as you're aggregating, you have to have some kind of ability to store some type of data to do the aggregation and get the result from it.
Yeah, there are memory devices that are modules that you can extend on there. Excuse me. So we have part of that platform and that backplane, you can put a GPU in there. So now you can do AI on the backplane. We have memory, we have devices that are storage devices that you can put on the backplane to get you, like a localized server as well. But it's got, in it, it's got web page development is right on there. So the HMI is kind of integrated into the device. So you just can port it out or display it on a standard monitor.
So you don't really need to store it.
Generally, the concept on edge computing is collect it, aggregate it, analyze it, and then forward it, or display it so that it actually be taken. But it's not long-term data storage. Then at that point you're pushing it you're going to put it out to a server, either on-prem or off to a cloud base.
That's the issue. Of course, one of the things, if you have a lot, getting that data pushed out, getting in IT folks, you got to get everybody to run a bunch of tape.
Correct.
And then it starts building to
a
big enterprise, which is always the issue.
And it is in this, and that's why if you can stay out of their realm and out of their lane and keep it kind of localized,
Yeah, conceptually it's really good, but then at some point you have to have the historical data. If you're only looking at the current aggregation of the real time or near real time data, then that's useful. But then how do you have some historical? You have to push it out somewhere to get the historical.
Yeah.
Pilot for long-term results, et cetera, et cetera.
Right. But if you're just exporting the result,
it's not so much.
The data is very minimal.
It's not so much data.
But you still need that
Need that conduit of information.
Understood.
That's the area I'm trying to-
And this is a cyber secure device, meaning it's forgive me, I'm not the most technical person, but it's got router functionality with whatever the cybersecurity standards are around that. So you don't have to add a managed switch with cybersecurity. It's embedded in the edge device.
We're trying to do stuff.
So the IT folks like that because we're saying this data is firewalled and it's going to be transferred on your certificate.
I'm trying to do stuff wireless because if I can do it wirelessly, I don't need
Yeah.
to send the IT folks around it all.
And so all the, like for instance, we did one not too long ago. Here's another. It was one problem, but the issue was something different. So the customer called and said, I'm in an OSHA lockdown for environmental reasons. And the issue was these guys produced parts that had a lot of outgassing and they had exhaust fans all over the roof, but they were not monitored. So, and these were belt-driven fans. So I think they went up on the roof and 4 of the 18, they were broken belts. So it wasn't exhausting the air. So we said, okay, we'll come in, we'll put energy monitors on each of these, bring it down to the factory floor. But we did all of that wirelessly because we couldn't run wires. So we have wireless devices to move data as well. But we find it better to just go work with IT in advance. A lot of times they're now saying we own that. If it's got an IP address, we own it. So whether it's an IP address that's connected wirelessly or wired, they still want to be involved, but we help roadmap. We've got a team that all they do is go out and do wireless network surveys. We do that a lot in the AGV market, right? Because all those wireless AGVs. So we'll say, give us this band, this spectrum. Yep. So we have a whole team that's what they go and do at the factory floor level. So it's always been a little, I don't know, voodoo it seems like to folks, but it's not. It's a really good way to move data without running wires. So. Yeah, and the technology with Wi-Fi 6 and 6E, now there's more bandwidth out there, and we can do it in what do they call them, private cell networks. That's the other thing. A lot of times IT saying, okay, if you want data wirelessly on the factory floor, you got to play in this space, which is so we have all the different wireless technologies. All right. Well, thank you for your questions and time. And with this, Denise, are we set for? All good? All right, thank you.
Hey, and we are back here at the Automation, Maintenance, and Reliability Summit in Cleveland, Tennessee at the Pi Center, Smart Factory, Peak Performance. I am here with Mike. Mike, you just finished your breakout session. It was fantastic. I could tell everybody was getting so much out of it. People watching at home, I'm certain that you are also getting a lot out of it. But I wanted to ask you a couple of questions about this. You talked a bit in your session about defining the problem. Mm-hmm. Why is that such a key piece of this and what you do?
Our company's involved, as you know, in the data collection of information on the kind of stranded information on the factory floor. Many times there's initiatives within these organizations to go find out and do an Industry 4.0 without really defining what they want to try to accomplish in the long run. So they do these programs, and many of them unfortunately fail because they don't have a defined outcome that they'd like to achieve.
So they're trying to dive in before they've even really decided where they're trying to go.
Yeah.
Right. And you were talking about data collection, and obviously Phoenix Contact, that's what you do. You help with the data analysis, data collection. Tell me a little bit about you were talking earlier about data points, and people sometimes think that they need all of this data, but they don't.
Yeah.
Tell us a little bit more about that.
Yeah, I think, again, when people think about Industry 4.0, a lot of what they hear are the Google and AWS messages of send us all your data and we'll make all your dreams come true. But it's way too complex of message, and really it's overwhelming for most customers. And quite frankly, most people don't have the budget to do this, or IT has a resistance to just provide all this data off the factory floor.
Sure.
So
that makes sense. So you're really trying to help them get a handle on it.
Yeah.
You know, something that's actually manageable.
Exactly. And what we found, Rob, is that many times it's only 3 or 4 pieces of data that we need to really get better insights into a defined problem.
That's
so
fascinating.
We first define the problem, then really the implementation only takes a couple, 2 or 3 data points, and we can get some better analysis.
So I'm the organizational manager, and I'm sitting there, I'm feeling overwhelmed. I'm feeling like I need to have all of this data. I don't even know where to start. And you're saying we just need 2, 3 data points to get going and to actually make an impact.
Yes.
That's fantastic. And I guess that would lead me into another piece of what you're talking about, starting small, right? Why is that important?
Well, again, a budget limits it.
Sure,
Somebody can
budgetary.
go find $5,000 somewhere in a budget, but to do a big implementation on a full digital factory is out of most people's budget. So start small. Again, define the problem. Start on a small application. In applications, we find boil into one of three areas. Either we're trying to improve quality, we're trying to improve machine reliability, which is the message here today, and also improved traceability and or energy. So those three things: energy, traceability / quality, and machine utilization.
It makes perfect sense. And if you're out there and you're watching this and you want to know more about it, how do people, Mike, how do people learn more about Phoenix Contact?
Sure. Our website is www.phoenixcontact.com, and we have a full line of libraries. You have white papers, case studies, all sorts of reference information that help you in your digitalization journey within your organization.
Well, thanks so much. Mike Brooks with Phoenix Contact. Fantastic breakout session. Thank you for joining us here. And thank you for watching. And there will be more after this.